The James Webb Telescope has essentially revealed the clearest picture of Proxima B in history, uncovering stunning bits of knowledge into a possibly tenable exoplanet. It obliges us, as we set out on an excursion through space, to uncover the insider facts of Proxima B and find out whether it could be the next Earth. We ought to take off into the vast expanse of space, where a mysterious planet exists in the habitable zone of its star, Proxima Centauri. This planet is not just any ordinary rock, it's reality. See, Proxima B is found a mere 4.2 light-years from us. This planet is covered in mysteries and wonders. Could it be another Earth, with seas and life blossoming on its surface? Anyway, wait, there's more. Proxima Centauri B isn't alone in that system. Around the red dwarf star, it has a companion, Proxima Centauri C. And who knows what other mysteries the star system holds. Maybe there's another companion that we haven't yet discovered. The secret doesn't stop there. Proxima Centauri produces roughly the same amount of energy from its star as Earth does from the Sun. Could this truly mean that there's water on its surface, and perhaps even life? As we explore beyond our own solar system, we encounter an entirely new universe of exoplanets, planets that orbit stars other than the Sun. With 200 billion stars in the universe, the opportunities for exoplanets are endless. Some exoplanets even wander freely, untethered to any star, like traveling nomads in space. Among them all, Proxima Centauri B stands out as an especially striking and captivating planet. It has a year that lasts only 112 Earth days and a distance from its star that is generally closer than Earth is to the Sun. Indeed, one side of the planet is constantly washed in sunlight, while the opposite side remains in everlasting darkness. Now, let's examine Proxima Centauri, the star that Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system. This system includes Rigil Kentaurus, also known as Alpha Centauri A and Alpha Centauri B. Together, these stars form the closest star system to our solar system. The two stars, Rigil Kentaurus and Alpha Centauri B, form a binary system known as Alpha Centauri A and B. These G and K-type stars appear as one star in the constellation Centaurus and are the third brightest stars in our night sky, with a peak luminosity of under 2.7. Proxima Centauri, also called Alpha Centauri C, is a red dwarf, or M-type star, found 0.21 light-years from the other two stars, typically about 4 times the distance between Earth and the Sun. It is the closest star to us. Proxima, in fact, means the closest star in Latin, and it was discovered in 1915 by Scottish astronomer Robert Thorburn. Despite being our closest celestial neighbour, it is not visible to the naked eye, having an apparent magnitude of 1113, much fainter than the human eye's limit of 6.5. Anyway, don't let that fool you. Proxima Centauri is still a star worth studying. Red dwarfs like Proxima Centauri are among the most efficient in terms of energy production. They may not produce a lot of energy, but the internal convection processes at their cores keep them shining for trillions of years. Generally speaking, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still debated. For one, it's a flare star, meaning it has frequent and intense explosions. As a low-mass star, its habitable zone would be much closer to it than the Sun's, projected to be somewhere in the range of 0.0223 to 0.054 AU, but it's not as habitable as it seems. Proxima B is bombarded by intense ultraviolet radiation from its star, regularly stronger than the radiation we get from our sun. That's right, it's so extreme that even the lightest particles of hydrogen are stripped away, along with nitrogen and oxygen. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima B may not have a stable atmosphere, which is essential for regulating temperature and maintaining a water-friendly surface. Without it, living creatures would be vulnerable to harsh space weather conditions, making life nearly impossible. So, while Proxima B might appear Earth-like on the surface, it is far from being able to support life. Scientists remain somewhat cautious, as there are many factors that render it inhospitable. The mission to reveal the truth about Proxima B continues, and some still hold hope. One tool that has garnered the attention of astronomers is the James Webb Telescope. After years of anticipation, the telescope was finally launched in 2018 and will help us determine if there is life on Proxima B. However, as with everything in science, things are never as clear as they seem. Several adjustments were needed to ensure the James Webb Telescope delivers accurate images, as Abby Tabor, a theoretical physicist at Harvard, explains. If a planet like Proxima B can absorb light from its star, it can also emit it as infrared light. The James Webb Telescope was specifically designed to detect infrared light. It can capture images of this light from the planet's surface and search for patterns that could confirm the presence of water or an atmosphere. But what if the planet has an atmosphere that's not conducive to life? The presence of an atmosphere doesn't guarantee the presence of life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus, with a thick atmosphere that is significantly denser than Earth's, and extreme temperatures that would make it impossible for life to exist. The journey to unravel the mysteries of Proxima B is not without its challenges. While the James Webb Telescope holds promise, there are other factors to consider. With costs mounting, space scientists are feeling the pressure to find ways to observe planets like Proxima B. Much is at stake, but the rewards are even greater. The opportunity to explore the unknown, to uncover the secrets of a distant planet that holds the potential for life, is a pursuit worth chasing. If the exoplanet were habitable, might we one day visit it? It's the closest exoplanet to us, which makes it so intriguing, practically like exploring our own backyard. Even more exciting is that it's roughly the same size as Earth, and its position in the habitable zone suggests it could indeed have conditions suitable for life. Proxima B's proximity also makes it an ideal target for our quest for life beyond Earth. With it being so close, it's a prime candidate for interstellar missions. Think about exploring this Earth-like exoplanet. Although we can't yet go there, it's certainly on the radar for future missions. As technology advances, it's one of the most exciting endeavors in the field of space exploration. However, it's no easy task. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. Nonetheless, a solution has been proposed: solar sails. These ultra-thin sails could be used to propel a spacecraft to the Alpha Centauri system, and Proxima along with it. This technology uses solar pressure to keep the spacecraft on course, eliminating the problem of running out of fuel. And here's something even cooler. This cutting-edge technology could provide insights into the possibility of life on other planets like Proxima B. However, like anything ambitious, there are limitations. For instance, the presence of an atmosphere doesn't necessarily guarantee the presence of life. Proxima B could be like Venus, with a thick, hot atmosphere that's inhospitable. Furthermore, get this: the James Webb Telescope can detect Such emissions, if they reach a brightness of only 5% of the planet's daytime side. Now 5% may not seem like much, but when dealing with a star that's generally dimmer than our own Sun, it's quite significant. If Proxima B has advanced civilizations, they may use bright orbital mirrors to reflect sunlight from the daytime side to the nighttime side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being gigantic gas giants, while others resemble our own Earth. But what do we know about them? One type of exoplanet that has caught the attention of space scientists is the gas giant. These planets are similar in composition to Jupiter and Saturn, but are much larger. Some of these behemoths have been named super Jupiters, surpassing even the largest planet in our solar system. Yet that's not all. There are also hot Jupiters, gas giants that orbit extremely close to their host star, existing in a scorching world with temperatures that could melt metal. Imagine seeing such a planet up close, with its furious storms and extreme heat. In addition to gas giants, there are also Neptunian exoplanets, which are similar in size to Uranus and Neptune. Among these are the hot Neptunes and small Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, with their atmospheres being difficult to study from a distance. And let's not forget the Earth-like exoplanets, which resemble our own Earth. These planets come in various sizes, ranging from smaller than our planet to twice its size. There are even super-Earths, which have masses more than twice that of our planet, but are lighter than Neptune. One of the most captivating exoplanets recently discovered is Proxima Centauri B, which orbits the star of the same name. This planet is classified as a super-Earth, with an estimated mass of 7 Earth masses. Although it is a relatively small exoplanet, it has sparked significant interest among astronomers and scientists due to its potential for habitability. Because of its position in the habitable zone of its star, there is the possibility that it could support liquid water on its surface, making it a prime candidate for life. Could Proxima Centauri B be the answer to the question of whether we're alone in the universe? Only time will tell as the quest for life beyond Earth continues. Proxima Centauri B remains one of the most promising targets in the search for habitable exoplanets. Its proximity, size, and position within the habitable zone of its star make it an intriguing subject of study for astronomers. Yet as we dive deeper into understanding this distant world, several crucial questions must be answered. Does it have the conditions necessary for life, such as liquid water on its surface? Does it possess a stable atmosphere that could protect potential life forms from harmful radiation? Or is it a barren rock, constantly bombarded by its star's intense flares, rendering it inhospitable? While the James Webb Space Telescope offers a new avenue to study Proxima B in greater detail, it is not the only tool available to scientists. Ground-based observatories and next-generation telescopes, such as the Extremely Large Telescope, ELT, under construction in Chile, are also being developed to observe distant exoplanets in more detail. These massive telescopes will allow astronomers to study the atmospheres of exoplanets, including Proxima B, and look for signs of habitability, or even life. The ELT, once completed, will have the ability to directly image planets orbiting other stars and detect the faint signatures of gases that could indicate biological processes. But even with the best technology at our disposal, the challenges are immense. Proxima B, like many exoplanets, is located incredibly far from Earth. Even with advanced telescopes, capturing definitive signs of life will require patience and perseverance. Detecting a planet's atmosphere is already a monumental task. Scientists must be able to distinguish between the light emitted by the planet itself and the light from its star, which can easily overshadow the faint glow of the planet. Furthermore, the presence of life, even if detected, is still a far cry from confirming its existence. Scientists need to look for specific biomarkers, chemical signatures that could indicate the presence of living organisms, such as oxygen, methane, or other gases that might be produced by biological processes. The idea of exploring other planets, especially one as close as Proxima B, also sparks the imagination. While sending humans to such distant places may be far off, robotic probes and space missions are steadily moving toward the possibility of interstellar exploration. Technologies like the Breakthrough Starshot Initiative, which plans to send tiny light-powered spacecraft to Proxima Centauri at 20% the speed of light, are pushing the envelope on what is possible. These probes would carry advanced instruments capable of gathering data on Proxima B and its atmosphere in real time, allowing us to analyze its habitability more effectively than ever before. However, even as we look forward to the potential for exploration, we must not overlook the ethical considerations that come with searching for life beyond our solar system. If Proxima B is indeed home to microbial life, or even more complex organisms, the discovery could have profound implications for our understanding of life's origin and its spread across the universe. How would such a discovery reshape our view of life on Earth? Would we treat it as a treasure to be protected? Or would we risk contaminating another world, as some have worried could happen with the exploration of Mars? These are questions that will require careful thought as we move forward. And then there's the bigger question: is Proxima B the exception? Or is it just one of many Earth-like planets out there? As technology continues to improve, astronomers are discovering thousands of exoplanets in a wide range of sizes, temperatures, and conditions. Some, like Proxima B, reside in their star's habitable zone, but the majority are very different from Earth. Some planets are gas giants that bear little resemblance to our world, while others might be rocky, but too far from their stars to sustain life. Yet as we build up a larger sample size, we may begin to see patterns emerge, indications of where life is more likely to exist, and perhaps where we might one day send a probe to search for signs of life beyond our solar system.